Unit 9, Lesson 3, we're going to start by asking you to solve this problem. Now, a couple key things to note. This triangle that we have is not a right triangle. In fact, if you figure out what that missing angle is, 33 plus 47 is 80 degrees, leaving you exactly 100 degrees for that top angle. Sine, cosine, and tangent do not work for triangles that are not right triangles. They are specifically for right triangles. So we can't do any of that at first, but what we can do is draw ourselves an altitude from the top of this triangle to the base, and the definition of altitude is it's going to create a right angle for us. So what we're going to do with triangles that are not right triangles is cut it into two right triangles instead. So what we have is this right triangle on the left, and we have this smaller right triangle on the right. And now I'm going to take those pieces and put them onto the triangle that we already knew. For example, this hypotenuse would be 14. We drew the altitude to create a 90-degree angle here, and we knew the 33-degree angle that was untouched when I drew the altitude. On the other triangle, I had the 90-degree angle from the altitude, I had my 47-degree angle, and I had side x. Looking at the triangle on the right, there's not enough information to figure out what x is. But if I knew one of those numbers, for example, if I knew this altitude, then I could set up a ratio and I'd say, well, that's a sine relationship. The sine of that 47-degree angle is going to equal the opposite side A over x. So if I knew what that altitude was that I drew, I could figure out what that missing side of x is. So that's when I look back at this other triangle. That altitude is on the triangle on the left. And what I have here is another sine relationship where I could say the sine of that 33-degree angle is equal to the opposite side A over the hypotenuse of 14. Now this I can solve for because I have enough information to do that. So let's go ahead and solve this equation. I would have to multiply both sides by 14 to get that altitude A by itself. So I essentially need to take 14 times the sine of 33 and punch that into my calculator. So I get 14 times the sine of 33, and I'm getting 7.62 for that altitude. And I'm going to use that altitude on this side of the triangle now. I now know that this is 7.62. So I can come down and finish working in my equation over here where I had said sine of 47 equals A. Well, now I know that that is 7.62 over x. So this problem becomes two sine equations. Now this is the other type that I have to solve by multiplying by x to get that out of the denominator. So that would leave me 7.62 is equal to the sine of 47 also times x. Now sine of 47 is just any other number, so we can multiply it, add it, divide it, whatever we want. To get x by itself, I need to divide by that sine of 47. So what I'm going to type into my calculator is 7.62 divided by the sine of 47, and that will equal x. So 7.62 divided by the sine of 47, and I'm getting 10.419, which I'm going to go ahead and round to 10.42. So to solve for x, I had to do two sine equations and work in those two right triangles, and I came up with 10.42. Now to find y is going to be a little bit more work because y has been cut into two pieces by my altitude. I'm going to call those two pieces x, I'm sorry, not x, we already used x. I'm going to call it w and z. So y, I know, is equal to those two pieces added together. So w would be on the triangle on the left, and z would be on the triangle on the right. So I'm going to have to figure out what those are. I could do a Pythagorean theorem now that I know that a is 7.62, but it's always a good idea not to use a number you calculated in case you calculated it wrong. So instead, what I'm going to do is, using the left triangle, I'm going to say the cosine of 33 would equal the w that I'm trying to find over the hypotenuse of 14. So again, in this case, I'd multiply both sides by 14 to get w by itself. So I need to take 14 times the cosine of 33, and I get 11.74. I'm going to do a very similar calculation over here on the other triangle to find z. I know that I have the cosine of 47 would equal that z that I'd like to know over the hypotenuse. Now here I can't avoid using a number that I calculated. I have to use that hypotenuse of 10.42, and I'll multiply then both sides by that number to get z by itself. So I need to take 10.42 times the cosine of 47, and I get 7.11 for z. So now that I know those two numbers, I can say, well, y is equal to w plus z, and we now know that w is 11.74, and we now know that z is 7.11. So when I add those two things together, 7.11 plus 11.74, I get that y is 18.85. So the whole point of this lesson today is that you don't have to have right triangles to solve missing sides, but we have to create right triangles to use sine or cosine or tangent. Now here's the best part of this lesson. I don't ever want to do this again. So what I'm going to do on the next page is take out the process of finding the altitude. So we're going to do the same exact problem, but we are going to do it with variables. So I've drawn the same triangle, and I want to make a special note here. So note that angle C is not a right angle. So this is going to work for any triangle ever. So what I did was I set up some equations. The first thing we did was draw an altitude. I'm going to go ahead and call that h, since I already had A is the side of my triangle and B is the side of my triangle. And special note, A usually refers to the side across from angle A, and B refers to the side across from angle B. So keep that in mind as we go through. So I set up the sine ratio that says the sine of angle A would be h over B. And then I solved that for h, just like I normally did in the last problem. I also set up the sine ratio for the triangle on the right, which says the sine of angle B would be h over A. And then I solved that for h. Since both of those equal h, the transitive property says cut out the middleman, and those two things, b times the sine of A equals a times the sine of B. I rearranged that a little bit to say a divided by the sine of A equals b times the sine of B. And this is what we call the law of sines.